Well, good morning, good afternoon, or good evening, depending upon where you are in the world, and welcome to today's DevOps.com webinar. I'm Charlene O'Hanlon, moderator for today's event, and I welcome you. As always, we have a great webinar on tap. I'm especially excited about this one, but before we get started, we do have a few housekeeping items we need to go over. First of all, today's event is being recorded, so if you miss any or all of the event, you will have the opportunity to access it later on demand. Following today's webinar, we will be sending out an email that contains a link to access the webinar. And we are taking questions from the audience. So if at any time during today's presentation you have a question for any of our panelists, please don't wait, don't hesitate, just use your GoToWebinar control panel and submit your questions. And we'll try to get to as many as we can before the end of today's webinar. Also, at the end of today's webinar, we are doing a drawing for 6 $25 Amazon gift cards. So please stick around. Hopefully you'll be one of our 6 lucky winners. All right, with that, we'll go ahead and kick off today's webinar, which is the State of Open Source Security and DevSecOps Pipelines, a panel discussion. Today's agenda is going to be chock full of information based on the security, the DevSecOps security survey that Snyk recently put out. We'll start though with introductions, and then we'll dive right into some of the survey results, including who's securing your software, some of the vulnerability reports versus the impact, and also securing container images. And then we'll from there we'll go ahead and do the Q&A. But before we get started with the conversation, first let's do some introductions. Our speakers today, panelists today, are Alyssa Miller, who is the Application Security Advocate at Snyk, and she's being joined by Ilan Rabinovich, who is the VP of Product and Community at Datadog, and Justin Cormack, who's the security lead at Docker Inc. Welcome to all of you. Thank you so much for getting up this morning and joining me on this webinar. I appreciate it.
Yeah, thank you, Charlene.
Lovely to be with you.
Awesome. Well, I'll tell you what. All right. Well, let's start by if you guys want to go ahead and introduce yourselves to the audience, tell us all a little bit about yourselves, and then we'll dive right into the survey results.
Sure. So my name's Alyssa Miller. As Charlene mentioned, I am an application security advocate here at Snyk. My role really is centered around, just as the name would imply, bringing application security conversations to the community, whether it's the developer community, the security community, whomever. And my background really is first as a developer. I've been a hacker all my life. I bought a computer when I was 12 years old and taught myself how to program in BASIC, not Visual Basic, just BASIC. By the time I was 19, I had a job as a developer for a large financial technologies company. And after doing that for about a decade, I got into security, where I've been ever since. So at Snyk, a lot of the stuff I get to do is to interact with folks like you at different events, but I also get the really exciting opportunity to do some research, which is ultimately what we're going to be talking about today, is the report that we just released, which includes a lot of data that we've mined from a number of different sources, and additionally a survey, as Charlene has mentioned. So really excited to share some of what we've seen and some of our ideas. With that, I'll turn over to Ilan.
Hey, thanks for having me, Alyssa. So I'm Ilan with the Datadog team. We're a monitoring and security analytics company. So we help you understand the health of all your systems and your applications and your customer experience. But also, we've also now begun working with our customers on helping to secure their infrastructure, helping them to understand some of the current state of the world around the security of their applications. So excited to be here. I spend most of my day either helping capture stories from our community and share best practices among them, as well as sort of using those stories to identify new problem areas we can help solve, like security or distributed tracing or other parts of our product area. So excited to be here.
I'm Justin Cormack. So I recently realized I've been working in container security for 5 years, which seems an awful long time. I've been at Docker for most of that time. And so I work on security among other things. I kind of work across the whole engineering org. at Docker. I'm also involved heavily in the CNCF SIG security and open source security work there, and I'm on the CNCF Technical Oversight Committee. And so I spend quite a lot of time looking at security projects that are coming along in the open source community and how people in the cloud native community are working with security and what's happening there. So it's a really interesting time to be in this space. I think it's like there's a lot going on. It's maturing in an interesting way, but there's still loads of work to do. So it's kind of fun.
All right. All right. Well, why don't we go ahead and dive right on into the content of the webinar. I know, as Alyssa said, we've got lots of survey responses and survey results that I think will really kind of help tell a picture or tell a story. Lots of graphics here that are going to really help organizations better understand where they stand with DevOps and DevSecOps and container security and such. So let's go ahead and dive right in. The first one here is a security responsibility, looking at the results from the 2019 survey and then the 2020 survey. And so in the survey that was included in this report, I know respondents were actually, they were asked to who they felt should be responsible for security, whether it was security or operations or developers. And it looks like from last year to this year that more people are attributing responsibilities to security and operations teams in addition to developers. So what impacts, Alyssa, does this shift in mindset have for organizations as they're looking to improve their security posture?
Yeah, so this was actually a really exciting development. As we looked at it last year, we were it was really ultimately disappointing, right? To see that when I asked people, okay, who's responsible for securing your software? Most of them pointed to developers. Okay, fair, that's what you would expect. But then the numbers that thought security and operations played a part in that were quite low. And so as we look at what's happened this year, and we see that, yeah, the same 80+% are saying developers, perfect. We want that. We want developers, and we want to understand that developers have a role in securing their software. And certainly for the last 2 decades, we've been trying to spread that message more and more with, diatribes like pushing left and so forth. But to see now that there's elevating awareness that, okay, we need the security team and the operations team to also be involved, it starts to build more of that collaborative culture. And when we think about DevSecOps, that's really what we're looking for, is this culture where everybody shares that same responsibility for delivering software, for making sure it's secure and making sure that it runs stably. And so I think that's promising, because otherwise what you saw with last year's results is that's an awful lot of responsibility to be putting on the shoulders of one group. Our developers, you're entirely responsible for securing your software. And oh yeah, by the way, meanwhile, we're giving you all this new stuff to deal with too, in terms of containers and all these, everything that you've got to do now from more of the infrastructure and ops side of things, because we're DevSecOps now. And right. I think seeing this shift in attitude and seeing that people are starting to understand within their organizations that these 3 areas really have to work together and understand what each other is doing in terms of security, and then have more of that common goal. I think that starts to bring us together, and it ensures that as technology keeps getting increasingly complex, we keep adding new forms of technology every day. This is what's going to enable us to be able to keep up and make sure that from end to end in our delivery pipeline, we're securing that software. So I don't know, Elon, what are your thoughts?
Yeah, I mean, I think we've spent the last decade or so talking about DevOps and getting dev and operations teams together, or at least helping them to use the same language and the same tools. And while I think security was likely in that original vision, we sort of lost them somewhere along the way in most organizations. And so as teams are moving much more quickly, it's a lot harder for, I think, for security teams to keep up if they're off on a silo. Similarly, if you're in a small organization, you may not even have a security team. So we have to sort of democratize this idea of democratize the same way we democratize deployments and monitoring and other concepts that were very specific to that just those ops guys that or gals that were sort of dealing with monitoring things in production. We expanded that to cover folks in the development side of the house as well as they're working on products that have visibility end to end. And we need to share those tools and share those experiences with the security teams and vice versa. They're going to come and teach us how to build better applications, how to build better infrastructure. We're going to bring our own experiences as well. And in the end, we'll all be better for it. But so just have to build that bigger tent.
There's obviously still a divide. I mean, these figures seem to show a divide, particularly the difference between, who's responsible for security in operations. Is a big divide where the developers are not taking responsibility, even though kind of the whole infrastructure as code things means it is code, and it's part of what you write, and you should you need to try and people need to be understanding it together what the security risks are, and that's clearly not happening as much. The 12% saying nobody is responsible, I mean, it's kind of low, but it's also kind of high. It's like, really nobody is responsible?
It's kind of frightening, actually, if you think about it.
I mean, at least almost everybody agrees that somebody should be responsible. I'm curious who those 2% were, and if they were just trolling us when they said that nobody should ever be responsible for security.
But there's a 10% difference between who is responsible and who should be responsible as well. Which is like, we know we need to do something, but we're not doing it.
Yeah, and I don't know how much that difference in slight terminology in the question means to that, but yeah, it is a little terrifying when you see 12% from last year saying, oh my gosh, yeah, this was nobody really. But yeah, and you bring up an interesting point, and that is that kind of the divide where we see 85% of developers are responsible for software security, but only 63% said infrastructure. And you start to wonder, okay, so we then see the elevation in operations come in there, which is great, and security is a steady 55%, which for me being a security person kind of makes me wonder too, like, we don't see security having a role in this, and I guess one of the things I kind of wonder when I see that is how much of that maybe is still this belief, especially in DevSecOps, that sec piece doesn't really fit, right? I think from a security perspective, one of the conversations I have quite often with the people in my network and in my community is, we as security have to do a better job of getting away from this idea of gates and starting to really become part of the development phases. And if you look at, even as go back to 2008, DevOps just starting to arrive on the scene, right? I mean, I think the first talk was given at the end of 2008 or early 2009, and so suddenly we as security, like, what are we going to do with this? Well, we're going to put up all these quality gates. When you go from, they're telling us that DevOps has all these phases, and so when you go from this phase to this phase, we put a security gate there, and that's exactly wrong. It's the thing that keeps security from being a part of the DevOps life cycle. And I try to put this in an interesting fashion, and it actually angers some of my security peers. And that is, we are guests as security. We are guests in that development pipeline. Software is going to get delivered. It's going to go from coding to deployment, whether security is there or not. Now, so we as security, we are guests to that pipeline, and in trying to influence it, we need to make sure that the things we do are frictionless. We need to make sure that we're bringing tooling, processes, training, all the things that we want. We have to do it in a way that developers can actually absorb that and leverage it without impacting their day-to-day lives. So, it's having tooling in the right places. a lot of times we tend to think DevOps and we immediately start thinking about automation. Well, yeah, automation is important if it's in the right places. But the big thing to me is we can't have those long feedback cycles of a quality gate where, hey, I've gone through my development, I've gone through my testing, now you do a dynamic analysis and you tell me I gotta go all the way back to coding again because there's all these security bugs. Why aren't you telling me about this sooner? And why aren't you telling me about that as I'm creating the code rather than waiting until we get to this point? And I think that that's going to continue. We need to be even more aware that now as we get deeper and deeper into this container world.
So do you think that security kind of needs to stop being invited to the party and just kind of, rather than be a guest at the party, so to speak, that to actually they need to kind of insert themselves in the process regardless? I mean, they obviously know that they're valued and they're necessary in the tool chain. So, why aren't they actually kind of being more proactive in being part of that tool chain?
Well, I think it's the opposite. I think what we've done in security is we've tried to shoehorn our way in there. We've tried to force our way in rather than how do we work collectively and collaboratively with these developers, and how do we make them want to do the secure things that we want them to do? How do we influence them? I shouldn't even say make them, but create that desire, like you would if you were a guest at a party. You're not going to just come walking in with food and say, this is what we're eating tonight. But if there's something that you wanted to bring, you might suggest, hey, let's I know a lot of people really like this. I make this, it's really good. How would you mind if I brought it along and your guests might like it? So it's a weird analogy as I'm hearing it come out of my mouth right now, but it honestly, it's the reality.
Yeah.
I'm curious what the other two on the.
I do think that, we do need to spend more time, helping people learn about why things are important and what we're trying to do and why things are, why things break in security. I think just helping people have a mindset of a security person about thinking about what can go wrong, think about what's going on. I think that really helps people a lot, just kind of understanding the concerns, and making the concerns more concrete and less kind of don't go and see what your brother's doing and tell him not to, as the old British children's do. Kind of like making the assumption that people are just doing things wrong on purpose, not helping people do things better and learn how to do things better. I mean, you mentioned, tooling is good. Tooling, security tooling is hard, and we need to. It's just building security software and security focused software is just a difficult thing to do to make it easy as well. And so I think we just have to spend more time working on those things. And but I think talking to people and helping them understand what we're thinking about and what the concerns are is really important.
I think part of it is also just an aligning of goals, right? A lot of what we did in the DevOps movement for the first, at the start was just getting people on the same page, right? We said, software, we said availability and, of your services are something that we all have as a shared ownership. It's very important that we, that we get software, not that you just get your software into Git, but that the software be running somewhere on a server and customers actually be able to reach it. And so it's a similar story, I think, here, where as we're combining efforts with security, like the security teams need to not be the team of no, they need to be the team of how do I help the business be successful and hit its launch, and then we work backwards from that to figure out how do we make that, how do we make that software not just launch and be available but also be secure. And then by doing that sort of that knowledge sharing and helping people understand the different ways and you can break, your code can be broken and used for evil things. We can help the dev teams understand that, but it's got to be that pairing, right? The way when I was in my former life as an engineer, when I saw the operations and dev worlds divide sort of break down quite a bit was when suddenly the ops team when we started going to like the development team stand-ups and being part of their conversations from the minute code was first written through the day that the service launched, because then we were part of that team. We had a shared interest in hitting a successful launch. And so if we can do the same thing with security teams, I think we can have similar, build some similar bridges. It doesn't mean we're all going to become security experts like Justin, and I assure you he will find more vulnerabilities than I will in anything any day. But you know, we can definitely learn from him and see how to be better and more secure. So.
Excellent. Well, in the interest of time, I think we need to kind of move on to the next slide and talk a little bit about open source vulnerabilities and you know, the reports versus impact. So you know, a lot of times when we think about open source security, we kind of think about the vulnerabilities that are actually reported in open source packages. But I think a lot of times what isn't really discussed so much is how that actually impacts the projects themselves. So I guess this year, or this year's report, actually, you guys did actually look at that and analyzed how vulnerabilities affected the projects that used packages that had open source vulnerabilities. So, but when it's all plotted out, it's kind of interesting that there doesn't really seem to be a correlation between the number of reports and then the projects that were impacted. So, Alyssa, why do you think that is?
Yeah, so this chart is probably one of the, I think probably the graph I'm most fascinated with, I guess, coming out of the report. So looking at the number of vulnerabilities reported, so we're talking literally like CVEs here, you know, vulnerabilities that exist in open source packages versus how many projects actually used that vulnerable package and were therefore impacted by it. And when we went to create this, the thought was, well, we'll see what's in the upper right quadrant, and those are going to be the types of vulnerabilities people need to be most concerned with. Mm-hmm. And then we got the results, and as you see, there is nothing in the upper right quadrant, and that was shocking. The fact that, you know, we can have hundreds and hundreds of cross-site scripting vulnerabilities reported in packages, but the number of projects that those packages impact is fairly small. On the flip side, you have this, you know, things like deserialization and prototype pollution, which are more complex vulnerabilities, right? They're not as well understood because, I mean, we've been talking about cross-site scripting since before it showed up on the OWASP top 10 in 2003. But prototype pollution and deserialization vulnerabilities, these are, you know, later to the game. They're ones that have shown up later on, and you see that smaller numbers of those had wide-ranging impacts. And so, for instance, you know, the case like prototype pollution, there were 3 vulnerability reports, so 3 individual vulnerabilities, but they were found that affected this in particular. But they were, the reason that they had such a massive impact is that they were found in open source packages that are widely used. Lodash, jQuery. I mean, anybody who's writing JavaScript code is probably using one or both of those. Mm-hmm. And so indeed, we saw that out of, you know, projects that we had scanned, we saw 25%. I mean, 1 in 4 projects had those vulnerable versions of those packages that now had this prototype pollution vulnerability. And so what I'd like to hope, now there's no good answer we were able to find. We did a lot of digging into this to try to answer the question, why exactly is there not this correlation? The one theory that seems to hold up best is that it seems like with those more mature packages, the more popular ones, the ones that if there's a vulnerability, it's going to affect a wide breadth of projects, they tend to be more mature. They tend to have been refined. They've eliminated things like cross-site scripting. They probably have common methods that they're using. They're working within frameworks for input validation. They're doing things like that you would expect. And so therefore you don't find those well-known, well-publicized vulnerabilities in new versions of those packages. On the flip side, where you are seeing those well-known, well-documented vulnerabilities still showing up as mistakes in code are in those younger packages that haven't gone through as much, you know, scrutiny. They may not have as many maintainers. They're not as popular. They're not seeing as much activity. And so a lot of those vulnerabilities just haven't even maybe yet been discovered yet. And so as they're getting discovered, that's where they're coming from, whereas they've been really pretty run out of the more popular packages. So that seems like a really logical approach to what might be going on here. But I'm willing to bet that Elon and Justin probably have some other thoughts too that maybe I'm not even thinking of here.
But yeah, it's a really interesting set of data, and I do wonder how it'll change over time as well, because some of these things, I mean, malicious packages have been growing very rapidly, but a lot of them have been quite targeted so far, and haven't got that, as you can see, haven't had a widespread effect on lots of packages, but they would be quite, serious if they have, and we're still kind of working on ways to work around that. But deserialization is kind of, I mean, it's a sort of fundamental thing that we're doing all the time, and there's been some really, I mean, it's been an issue for a long time as well, in the same sense as XSS is. I mean, I remember that, Ruby and PHP have had those vulnerabilities for decades as well, and they've been quite serious, and it's something that you kind of would have hoped that the widespread libraries had it right now, and it's kind of worrying that they haven't. So yeah, it's I'd be really interested to see how these change in the next few years as well.
Malicious packages is the one that always grabs the headlines, right? It's like some Node.js somewhere, developer somewhere had their package replaced with a Bitcoin miner or a Ruby developer or whatever it might be, and everybody pulled it down. I'm curious if the fact that like the number of projects impacted was a little low, was that, are we getting better at version pinning? Like I know, at least in the container game, we see many of our customers are just pulling down the latest image tag all the time, even on sort of base open source images that you would think, they might lock down. So a bit more. So I'm curious if, in our software development practices, or at least within the open source world, if we're getting better at pinning rather than just always grabbing the latest library or the latest version that might, get picked up on the next, so that it gets picked up on the next build. So I don't know. That's the one I'm interested in tracking over time. I know it wasn't in the 2019 report, but I'm curious to see where it lands in 2020 and 2021.
Yeah. No, I agree. And I think you are going to see us probably pay more attention to that one in particular, just because, like you said, it gets a lot of press. There was just an article, I think it was in Tech Target a couple weeks ago, about malware code that had been kind of been making the rounds through a number of different open source packages. And yeah, I think, version pinning probably is a big chunk of that. And what's interesting with version pinning is, at least that's something where there's not just a security implication to it, but there's a functionality implication to it, right? Yeah. And I think devs have gotten better at recognizing, like, I need to make sure that I keep that version consistent, even if it's not the latest and greatest. Yeah. That's the version that I need, because subsequent versions could break it. And
there's an alternative to it as well, though, which is, we've all worked in that company that, where you're pinned on some 10-year-old version of a library that's guaranteed to be riddled with security holes. So you have to, it both saves you work and creates more work for you at the same time. So
yeah, and in general, you're better off upgrading, I think. There's also some really interesting work in JavaScript space about restricting the capabilities that imported libraries can have, so that the library you're using to do regexes can't use network traffic and things like that, which are actually kind of, I think, good longer term mitigations for some of these things, where, it's if you can restrict the scope of what your libraries can do, then you've actually got a better, you don't have to read every line of code that your indirect dependencies are bringing in, which is just a huge amount of code to understand and maintain.
No, and that's a critical thing, right? Just even understanding what are you introducing to your code when you introduce a vulnerability. I mean, this is, or a new dependency rather. This is something that we talk about a lot, right? I mean, when we think about the idea of software bill of materials and software supply chain security, even you add, NPM is probably the one that's most notorious for this. In fact, we see it from the Snyk side when we do these vulnerability scans of people's projects. We find 85% of their vulnerabilities are coming from indirect dependencies. So those are the dependencies of their dependencies. So I add 7 dependencies to my JavaScript project. we all know what happens, right? You go there and you open that project and you sit there and you wait for NPM to go update all your dependencies. You go get coffee, maybe dinner or something. You come back, it might be done. Because what you find out later is, oh yeah, my 80 lines of code with those 7 dependencies turned into 730,000 lines of code, and there were an additional 59 sub-dependencies I didn't know about. And that's where we find a lot of the vulnerabilities, because people don't have the visibility into that. And NPM, Java, you know, those 2 ecosystems in particular, they're really built on that idea of that modularity and building upon one dependency on the next that way. And so we tend to see a lot of it in that space in particular.
I mean, in some of the younger languages, also what we see is that, you know, that like a lot of these libraries that everybody ends up depending on are, you know, they're capabilities that we wish the language had, and they just don't have in the current, you know, in the current iteration. So, I mean, even something as I remember a couple years back, we had like the big left pad controversy in NPM where like somebody yanked that package, right? Why isn't that just a function that was like part of Node.js? Well, now it is, right? And so if you think back to, I don't know, this is not new. I mean, going back to like the days of CPAN and Perl, like this is the module community has just been always the way in which we enhanced our languages. And so as those things move lower in the stack, we get, you know, a little bit more control, a little bit more quality over them.
For sure. Awesome.
But yeah, I mean, but the JavaScript model, I think, is, you know, admirable in that like small pieces of specific, well thought out functionality as modules is a really good idea, rather than gigantic chunks of library that do a lot of things indifferently. I mean, you know, it's the way that software reuse was supposed to happen, and that's why I kind of think that that is the right way, and we shouldn't be discouraging people from building software like that.
Yeah, I mean, it creates challenges, right? There's this whole idea of package health. How do I make sure that that new package that I'm going to pull into my application, this new dependency I want to add, how do I make sure that I'm grabbing the right one? How do I make sure that I'm, you know, that this is a project I can trust versus, okay, this one, you know, that there's not a good trust level there. And I think that's something that begs a lot of interesting discussion too, when we as we get more into, you know, how do we, as we're building those modules on top of modules, because now you have that situation of, you know, is this package, you know, does it have a lot of commits because it had a lot of problems, or are there a lot of commits because there's just a lot of maintainers adding functionality? You know, the high number of commits can be a good or a bad sign depending on other factors. And so then it's, okay, maybe I look at the number of stars. Well, how much do I really trust the community? And okay, great, this one's got, you know, a couple 100,000 upvotes. That's probably a pretty good sign, but there's no guarantees. And you know, so we can cycle through all that, and it honestly takes a lot of analysis. And I think for organizations, there is no one right answer to that, right? But you've got to have a plan. You got to understand what the metrics are that you are going to follow, but you got to be able to tie those metrics then together. So I think as we see that continued growth in NPM in particular, I mean, not to pick on them, but that ecosystem has seen massive growth. And so as we do that, I mean, it's probably going to become more incumbent upon even some of the repos to provide some more of that tooling, or tools like the ones that we all represent here as well, to be able to provide better visibility into that, and give access to some of those metrics beyond just stars and commits. But you know, what does it really mean? How do we develop a more comprehensive score? I'm curious if you guys have had any success in that space.
Yeah, I mean, I think that even CVEs is a dangerous measure, because like no CVEs either means very secure or no one's even looked at it, and just not being able to distinguish between those two cases is like, and lots of CVEs means spent a lot of time looking at it, found lots of issues and fixed them, or it means terrible code which you should never use. It's going to have infinite number more. I mean, even those kind of metrics are just difficult to interpret without really looking at what's going on. And I'm not sure I do have any useful measures, except, I mean, often I find that actually working with a project when they have a security vulnerability is often the best way of getting a feel for how they respond and what kind of issues they take seriously or not seriously and those kinds of things. But that's often something you can't talk about directly as well. So it's one of the difficult things of working in security. Sometimes there's a lot of things that you actually have a good feel for things that you can't really tell other people.
But it's also more of a qualitative score. Like, how do I trust a project based on the fact that Justin or Alyssa have worked with them in the past at some point and might have had a good experience, right? I can't put on that on a graph or in a GitHub badge. So it's an interesting one.
So we're about 25 minutes to the top of the hour, so I want to go ahead and keep us moving. So why don't we go ahead and move on to the next slide here, which is building secure containers. And this is, I'm sure, a slide that a lot of folks are really interested in, because, as we all know, that containers are really increasingly becoming part of the security conversation, especially when we're talking about software security. So, developers have a lot of capability to define the infrastructure that's going to host their code. And so with a lot of open repositories like Docker Hub, for example, making container images available, it really should, it seems like it should be easier for developers to, to kind of, have these secure containers, but the report is actually kind of suggesting something completely different. So Alyssa, what is, when we're talking about security, what does this tell you about the use of containers and how official images should be utilized?
Yeah, so first of all, welcome to the most exciting and most boring graph in the entire report. And I say that because it's exciting because there's a lot of really good data here, but at the same time, it's boring because nothing changed from last year to this year.
Oh boy.
So last year was the first year in this report. We do this report annually. Last year was the first year that we looked at container security through this lens. And what we did was we simply pulled the top 10 most popular official images, and we analyzed them for vulnerabilities. What known vulnerabilities did they contain? And so it's a simple process. Just pull the latest tag for each of these of the 10 most popular, and you run them through, and the results were staggering. To see, I mean, in particular, obviously node, you see that here, it's an outlier. We had to actually break the scale to fit that node image vulnerability count on this graph. But this isn't to belabor the people who are responsible for managing these container images so much as it's a reminder to those folks working in a DevSecOps pipeline that just because you pull a container from a repo and that container image is marked as official, that's not a guarantee that it's secure, and it doesn't absolve you from having to do your normal security hygiene. And I think that's where we run into issues right now. I'm not going to name and shame, but I did read, as I was working on this part of the report, I actually read a blog from someone pretty well known in the developer community talking about how to build a secure container image for your application. And right there in the blog, sure enough, it says, well, if you go to Docker Hub and you pull the official image, you should be good. Well, no, you still have to be aware that official image doesn't mean secure image. Let's be clear. There are very different meanings there, and you can't make that assumption. You still have to be aware of what are you introducing to your environment. This stuff is code now. It's a container image. It's essentially code like anything else. So need to be looking at that the same way we look at any other open source. If it's introducing these libraries, are those libraries filled with known vulnerabilities that shouldn't be there? And then we can start having the conversation around, yeah, how do I minimize the images that I'm using? If I pull node latest, I get the node buster image. It's a big, heavy image. It's got image processing libraries, and it's got all sorts of libraries that most of the time you don't need, and it's based on ultimately at the core of it, it's based on a vulnerable Debian platform. So, but if I go and I grab Node Slim, suddenly those 642 vulnerabilities you see on your screen there drop down to 45. So that's like almost 95% decrease just by limiting the contents of your image. So there's a lot of things that can be done here, but I think a lot of it comes back to you just need to be aware that your standard security practices are still required here, even if you're pulling a official image.
I mean, yeah, I mean, the first thing to note is you're much better off pulling the official image than some image that's not maintained at all, which will, like, where even if the number of vulnerabilities looks low, they might well be older, more serious ones because they haven't been updated, and you have to be really careful. So the official images are still a better starting point than not starting there. You're definitely better off, as you say, just taking the stuff that you actually need and not everything. There's a real trade-off between like convenience and putting everything in versus something that's customized for you. There's also a lot of other kind of things to bear in mind. Like, so the node image is based on Debian, and Debian, the default node, there's Alpine node images and things that are different as well. But the Debian doesn't fix a lot of vulnerabilities quickly. They tend to mark them as either doesn't affect us or not terribly important, and we'll fix them when we upgrade in the next release and things like that. So you have to understand that, like, Debian's kind of policy, which is where the underlying packages are coming from for these, so that they you know, they don't tend to fix things fast. Ubuntu clearly have, judging from this, have actually changed their policy, and they seem to be fixing things faster, although some of it might be just the sample period. But I think that these policies do change, and the amount of stuff you're getting. I mean, also that could be just because Ubuntu removed stuff from the base image, and the base image is now smaller as well, because a lot of the base images have got smaller and less dependencies by default. So it depends exactly on the timing. I'm not 100% sure about that, because I know there was an effort to make some of them smaller. But yeah, you know, we're living in a world where most of the software has vulnerabilities most of the time, and most of them are not critical, but you need to, if you want to understand what these things are, and whether they matter for your use case, it's obviously, you know, it's a difficult world to be in, and you really need to know whether those vulnerabilities are, you know, significant or minor ones, and how long they've been there, and all those kinds of things, which you kind of need the detailed dive into the, you know, the information that the Snyk scanning tool gives you, rather than just kind of looking at a number to see what's really going on.
Yeah, I mean, I think this is likely why you, to some extent, pick these containers. But if I, you know, images. But if I look at like Datadog's container adoption studies and map them to this, like the fact that, you know, Postgres and Nginx are always sort of trading first place in the most popular base, you know, default images that we see, and those are, you know, those have quite a high number of vulnerabilities. So it's definitely concerning. But the question is, again, how many of those are actionable, like Justin was saying?
Yeah, I mean, I think the number of vulnerabilities in the kind of base Nginx config has been relatively very low over the last few years. But I mean, the problem is that you don't know what features people are using, because Nginx is a very big thing, and there's loads of config. I mean, most of the, I mean, I can remember some issues with some of the regex support in Nginx from a few years ago. But I mean, like, there's 1,000 features in Nginx, and you can turn them on and off and use them or not use them, and you may or may not be vulnerable. And those things are really hard to know up front with a very general purpose image.
Yeah. No, and the thing I've been telling people, and it's unfortunate, right? Because I literally see people's faces drop when I say this. These are the exact same problems we faced when we were talking about, you know, steal hardware and installing operating systems. We were talking about coming up with hardening guides and standard images and golden images for how we were going to build servers in on-prem environments. We've moved to containers, and while it's made that a lot easier, a lot of the same concerns still exist. How do I minimize access, and how do I, you know, if I expand this into we start thinking about then, okay, if we launch in a Kubernetes cluster, and now you start thinking about all the additional complexities there and the controls that provides us, but how do I make sure that I'm implementing the right controls with even just things like limiting CPU utilization and memory, and how do I ensure that that container doesn't have root access and things of that nature. Just it's a lot of the same conversations. It's just become, I think, ultimately easier to manage from an automated perspective with tooling now, because it is all defined in Docker files and Helm and so forth. We can look at that stuff programmatically rather than necessarily just having to review a checklist or something like we used to do, quote unquote, back in the day.
Yeah, absolutely. I mean, it's easier to understand what's in your container and what's going on, and it's easier to update it, and it's easier to fix these issues. So, and roll out new containers and things like that. I mean, with a bare metal server, things used to sit there for years without being updated. So I think we're in a much better situation. We've got better tools that let you analyze what's in your containers. I mean, like we never had these graphs for how many vulnerabilities there are on your Linux distro a decade ago. The answer was, a lot. But like these base images are way smaller than anything you would have put on a VM, and you can really take them down to just exactly what you need for your application if you spend the time doing it, and that will really cut down your attack surface. And so, a lot of this stuff is just way easier now than it used to be.
I mean, I think the other piece that I think we've talked about here is just that making this much, because everything we do now does have an API around it and can be codified. Like it's, you want to know what's coming on your Kubernetes clusters or make sure that it's been scanned. Great, let's, there's set up an admission controller, and it says you can't run random containers out there. They have to have gone through, some checks or policies or what have you. There's that also has the downside, which is if you expose those APIs to the internet, somebody's definitely going to run a crypto coin miner somewhere in your Kubernetes clusters. But at least you have some control over what's running there, and much more visibility than you did to that server sitting under somebody's desk, in the office somewhere.
All right, great. We are doing a time check here. We're about 13 minutes to the top of the hour, so I think we kind of want to start wrapping things up. Let's go ahead and move into the question and answer period. Great information, by the way. Those charts were really fascinating. We've gotten a lot of questions in from the audience, but there is a little bit of time. If you have a question, please go ahead and use the GoToWebinar control panel and submit your question, and we'll try to get to as many as we can. Here is one that's kind of interesting, I think. In critical infrastructure environments, such as production telecom networks, how does the CD part of the DevOps pipeline do, quote unquote, in-service upgrades of security updates? SLA for call completion can be 99.9%, no disruption, and call reconnect in milliseconds. It sounds like that's a tough thing to have to deal with.
Yeah, I mean, it's an availability concern more so than anything, obviously. And I think this is where some of those high availability cluster configurations come into place when we start thinking about things like Kubernetes. Now, it's great if you have a container environment where you can do something like that. It becomes obviously more challenging when you're talking bare metal servers, but we've come a long way in terms of high availability solutions and so forth, and that's really been the crucial key. But to make that work, the end, it's what you would expect for CI/CD, right? It's all about the automation at that point, because you need that automated capability to deploy that new update, which ultimately should still be coming through your complete pipeline, whether it's a security update, whether it's a patch, whether it's a fix to code of your own. It should always be following that same pipeline, but you need that capability. So you need that level of automation that's going to allow you to deploy it to that production environment while managing that high availability solution. So in other words, taking down one side of a cluster having that capability and the capacity, quite honestly, there's a capacity planning issue here too. If your cluster, you don't have the resources to be able to update one node on the cluster at a time and have the other nodes, however many there are, maintain connectivity, that's an issue. But as we see with cloud native environments and the fact that we can expand and spin up new nodes as quickly as we need them, that's where, again, getting that in an automated fashion. So if you want it to be part of your continuous deployment, if that's automated and you're able to do that, that provides a wonderful capability that we never had before. And so it actually has gotten progressively easier again, I think, as we look at this. But I'm definitely curious on some other thoughts for this one in particular.
Yeah, I mean, I think it just goes to, it's a change. It has to, the CI/CD concept doesn't come, without also thinking about the operationally how our software, is architected, right? So if you are in a spot where you're just buying one appliance and it is a sealed box and you cannot touch it for 20 years because that is the way, critical infrastructure, was built in the past, is you drop it off in some concrete somewhere and then you never look at it again. Well, then yeah, it's gonna be hard to see, to continuously deliver that. But if we're building these more sort of distributed architectures that are more easy to do rolling updates on, more easy to do these deployments on, then it's then the CD part, I won't say it comes for free, but it's actually viable. So we have to just rethink the entire process, not just the deployment piece.
Yeah, absolutely. I mean, I think that it's important to think about, I mean, the whole idea of cloud native software, that kind of idea is about thinking about these things. It's about thinking about how do I maintain my software over time, not just ship it once. It's how do I have this ongoing process where parts of it are being changed out and switched and updated and upgraded and secured and re-implemented while I maintain service the whole time. And that it's a whole mindset about software isn't something that you ship once and then you wonder about it. Software is a process of how you live with services that are on computers.
All right. Let's see if we can get another one in here. Here's one. Popularity and upvotes aren't direct indicators of source trustability. How do we develop patterns for better trustability or a brand of trust? And how do we better assess risk?
So I'll approach this in two ways. First, I'll tell you what a lot of work that's been going on is actually centered around machine learning with this. And I always hesitate to even mention the words machine learning because in the vendor space, of course, that's a term that's getting thrown around a lot. But it is, when we go to the core of what machine learning is, you could do this without machine learning too. It's just harder. It's building that model, right? So like we kind of talked about before, where this part, any one particular metric I may look at, when its numbers are high, so take CVEs, that was a great example from Justin before. If you're looking at the number of CVEs on a package, a high number of CVEs could be a good or a bad thing. It could be good because it indicates there's a lot of activity going on in assessing that package for vulnerabilities and you're identifying, or it could be a sign that that package just continues to see a lot of insecure code being introduced through new commits and so forth. So it's about building a model around that. So how do I, if I know that those two scenarios, those two diametrically opposed scenarios to the same metric exist, what other metric then can I map into that is going to help me discern, okay, this one has a high level of CVEs because there's a lot of different, there's a lot of different vulnerabilities being identified from a number of different sources. That might be a case of, okay, yeah, it's getting a lot of attention versus, hey, this one has a high number of CVEs. There are a lot of the same repeat issues over and over again. So if I'm looking at maybe the vulnerability type, that tells me then, okay, this package is just not doing well as far as being maintained. And then the same thing on the opposite end. You got to think about the low end. If the numbers are low, is it because, hey, there's a lot of, maybe you look at then the activity. There's a lot of PRs. There's a lot of, commits going on, but there's not a lot of security vulnerabilities being found, that's a pretty good indication that, yeah, it's probably pretty mature package, versus if it's low, but you don't see a lot of activity in that package, it's not very popular. Well, now that's probably a sign, maybe that's one I want to stay away from, because it probably hasn't had a whole lot of scrutiny.
Also, I think that the Linux Foundation has this project called the Core Infrastructure Initiative, which is really about helping people grow the maturity of their software process. So it gives you badges based on things like, do you have CI, and do you have security processes? And there's a whole set of really detailed things about helping people think about the process by which they deliver software. And you can have a good process that delivers bad software, but actually in general, a good process that does help people think about delivering good software, and that kind of maturity of that, I think is a really helpful thing for people to think about and understand how, just think about the process. How do we deliver software as a team? Are we doing it in the best possible way?
All right, great. So we are about 5 minutes to the top of the hour. So unfortunately, we have to shut down the question and answer period time. I apologize if we didn't get to your question, but please know that the folks at Snyk will be getting a copy of all of the questions that came in, and I'm sure they will be more than happy to follow up with you offline to get your question answered. Also want to remind the audience that today's event has been recorded. So if you missed any or all of the event, or if you just want to watch it again, you'll have the opportunity to do so. We are going to be sending out an email following today's webinar that contains a link to access the webinar on demand. And the webinar is also going to be living on the DevOps.com website. So you can always go look there. Just go to DevOps.com/webinars, look in the on-demand section, and it should be right there waiting for you. All right, before we close things out, I did at the top of the hour, I did mention that we were going to be doing a drawing for 6 $25 Amazon gift cards. So let's go ahead and do that real quick. Our first winner today is Bonnie S. Second winner is Colleen W. Third winner, Eric with a K, J. Fourth winner is Jim H. Fifth winner today is Mark S. And our final winner today is Edward N. Congratulations to all 6 of you. We'll be sending you your $25 Amazon gift card by email, so please check your inbox. If it's not there, check your spam folder. Ilan, Alyssa, Justin, thank you all so much for such a great presentation, so much good information. And Alyssa, if folks want to take a look at the survey, get a copy for themselves, where would they go look for it?
Easiest place is just snyk.io. There is a link right on the front page. If you can't find it, just go click on the blog link. You'll find it pretty quickly. But yeah, easiest way, just right through our website, and we'd be happy to share it.
Awesome, awesome. Well, I hope we all meet again this time next year and talk about next year's results.
Sounds great.
Looking forward to it.
All right.
Yeah.
All right, great. Well, thanks all 3 of you for joining me today. Also want to thank the audience for joining me. I really appreciate it. But for now, this is Charlene O'Hanlon, and I am signing off. Have a great day, everybody, and please stay safe.